All right. Let's have a look at the solution of example 3. All right. First of all, dy by dx plus 3y is equal to e to the 2x is a first order linear differential equation. The solution is going to be y e the integral of p dx is equal to the integral of q e the integral of p dx. Um, we all know that p is equal to 3. P would be the constant or the function in x only in front of y, and q would be equal to e to the 2x. So therefore my solution is going to be y e the integral of 3 p dx, sorry, that's madness, p the integral of 3 dx, and that is equal to the integral of q, which is e to the 2x, e the integral of 3 dx. I will. So this is the integral of, sorry, this is y e to the 3x. When you integrate 3, you get 3x, and this is e to the 2x, e to the 3x, and this is dx. This is the same as saying the integral of e to the 5x dx. So if you're multiplying on the basis the same, you add the indices. When you integrate e to the 5x, you're going to get back e to the 5x. Then you have to divide by the differential of the inside function, which is 5, plus the constant of integration, which is c. So what we have is y e to the 3x is equal to e to the 5x over 5 plus c. Divide the entire equation by e to the 3x. We're going to get y is equal to 1/5 e to the 2x plus c over e to the 3x. Alright? And this would be equal to y is equal to 1/5 e to the 2x plus c e to the minus 3x. Alright? So that would be the solution for example number 3. The general format for first order linear is dy by dx plus py is equal to q. And in order for me to solve the first order linear, I've got to get it in this format. Alright, so to get it in this format, I'm going to divide the entire equation by x plus 2, don't it? So I'm going to get dy by dx plus y over x plus 2, and this is equal to x plus 2 squared. Do you agree? Once in this format, I can say that p is equal to 1 over x plus 2. I can also say that q is equal to x plus 2 squared. Alright, do you agree? Alright, so the solution is y e the integral of p dx, which is equal to the integral of q e the integral of p dx. Alright, putting in our stuff, putting in p and q, we have y is equal to e the integral of 1 over x plus 2 dx, and this is equal to the integral of q, which is x plus 2 square, e the integral of 1 over x plus 2 dx. We're good so far? Dx. This becomes y e to the ln x plus 2. Do you agree? Talk to me now. And this is equal to the integral of x plus 2 square and then e ln x plus 2, alright, dx. But e x plus 2, e to the ln x plus 2 is just what? X plus 2. So what we have is x plus 2 square, the integral, times x plus 2 dx. So right now we have the integral of x plus 2 cube. Over the left hand side we have y e to the ln x plus 2 is x plus 2. We already determined that already. Now let's integrate. Alright, if we integrate here, we're going to increase the power by 1, divide by the new power, and also divide by the differential of the inside function. So this becomes x plus 2 cube. Sorry, that's not cube. X plus 2 to the 4th power. Divide by the new power, which 4, times the differential of, and also divide by the differential of the inside function, which is just what? 1. Plus c, which is the constant of integration. Alright. So divide the entire equation by x plus 2. If I do that, I'm going to end up with y. I'm going to end up with y is equal to 1/4 x plus 2 cube, don't it? You agree? Plus c over x plus 2, don't it? So y is now equal to 1/4 x plus 2 cube plus c x plus 2 to the minus 1. Do you agree? Alright, example 5. Alright, this is already in the correct format. So the correct format would be dy by dx plus py is equal to qx. Sorry, q is equal to q. So it's already in the correct format where p is equal to tan x and q is equal to sin x. Do you agree? Alright, moving on. So the solution of this differential equation would be y e would be y e the integral of p dx. Alright, let's write out the solution. P dx is equal to the integral of q e the integral of p dx dx. Alright, so this is going to be y e the integral of tan x dx, and this is equal to the integral of q, which is what? Sin x, times e the integral of tan x dx dx. Alright, when you integrate tan, you're going to get what? Ln sec. So y e ln sec x is equal to the integral of sin sin x e ln sec x dx. Ln sec x, e to the ln sec x is just what? Sec x. So this is y sec x is equal to the integral of sin x sec x dx. But sec x is just what? 1 over cos, don't it? So this is really the integral of tan x, don't it? Dx. And again, the integral of tan x is what? Is ln sec x plus c, the constant of integration. So to solve fully now, I just divide the entire equation by what? Sec x. So we're going to have y, so this is y sec x, divided by sec x, sec x, sec x. So this is y, this is going to be y, and that would be equal to, sec x is 1 over what? Sec x is 1 over cos. So this is going to be cos x ln sec x plus c cos x, don't it? It's alright. We'll come back to it. Alright. What else? He did give us some values of thing there. In number 5. It's number 5, right? He said when x is what? 0, y is 1. And I told that this is so that we can calculate the constant of integration. So 1 is equal to cosine 0 ln sec 0 plus c times what? Cosine of 0, don't it? The cosine of 0 is what? 1. So this is 1 ln sec. Sec is 1 over what? Cos. So that will be what? 1 over the cosine of 0. The cosine of 0 is what? 1. So that's 1 over 1, which is what? 1. And ln 1 is equal to 0. So this is multiplied by 0. We're good? Cosine 0 is what? 1. So this is 1 times c. So it's c times 1. So essentially, c is equal to 1. Agreed? So therefore, if I rewrite this equation, and I'm looking for space to do it. If I rewrite this equation, I'm going to get y is equal to cosine x ln sec x plus c, which is 1, plus cosec plus c cos x, but c is 1, so it's just what? Plus cosine x.